How did the universe begin? The truth is, we don't know. And up until a certain point, our current theories and understandings of the laws of physics began to break down. Gravity and quantum mechanics clash, leaving the greatest mysteries alive. We can only describe what happened after the first moment, not before it. In fact, the concept of before does not even make sense, as time was likely created when space was created. Luckily, the recurrent human need for self-discovery has allowed generations of scientists and countless research efforts to trace the estimated origins of everything to have taken place approximately 13.8 billion years ago. Everything that has and will exist came from this expansive event. We know this as the Big Bang. Currently, it is our best scientific model for explaining how the universe expanded, rather than an explosion from nowhere. It was space itself that was expanding. So, around 13.8 billion years ago, the universe existed in an extremely hot and dense state, and then it started to rapidly expand outward in all directions exponentially, all in less than a second. This is known as cosmic inflation. During this initial expansion, the high energy created fundamental particles like quarks and electrons. As the expansion continued, the universe began to cool, allowing quarks to combine into protons and neutrons. These combinations formed the first atomic nuclei of hydrogen and helium. This was just in the first 3 to 20 minutes. This continual expansion and subsequent cooling went on for about 380,000 more years before the first hydrogen and helium atoms began to form. Finally, the universe reached a temperature where electrons could bind to the atomic nuclei without the immense heat separating them. This period is called the era of recombination. Before this, the universe was a hot, opaque fog of particles. After recombination, the universe became transparent, letting light travel freely for the first time. This leftover light is what we see today as the famed cosmic microwave background. It's the oldest light we can observe. It's also the best evidence we have for these events actually taking place, and for the Big Bang Theory itself. After recombination, the universe entered a period known as the Cosmic Dark Age, a time without galaxies or stars. Even though the universe was now transparent, where light could travel, nothing had created significant light to burst through the emptiness. In the vast space, only a dense fog of neutral hydrogen atoms occupied it. The universe would remain in this darkness for hundreds of millions of years. What gradually broke this period of darkness were the first stars, which were clumps of gas pulled together by gravity. They are referred to as population 3 stars, and are thought of to have been massive, but lived shortly. Their intense ultraviolet light broke through the dark fog and started the period of reionization. Along with stars, tiny galaxies began to form. They were small and less structured than how we know of them today. Recent observations from the James Webb Space Telescope suggest that some galaxies appeared as early as 100 to 300 million years after the Big Bang, much earlier than scientists thought possible. These galaxies continue to grow, collide, and merge over billions of years. The Milky Way, our galaxy, likely started to form around 13.6 billion years ago, just a few 100 million years after the first stars. It would be constructed over billions of years as smaller galaxies merged due to gravity's pull. The Milky Way would grow into a large spiraling galaxy with billions of stars, one of which being our sun. Around 4.6 billion years ago, our solar system began forming from a rotating cloud of gas and dust called a solar nebula. Gravity caused most of this material to collapse into the sun, while the remaining material gradually formed the planets, moon, and other objects that orbit it. One of those planets was Earth. You know, the planet you're on right now. We took a look back at how the universe started and where it led. Fascinating, of course, but there is still so much we don't know and probably will never know. Even now, the universe is constantly expanding. The light we see in the sky from distant galaxies and stars are remnants of our ancestors. Billions of years have gone by, and billions of years will follow. But we won't see most of it, so don't worry.